Guys, Miss Pearso here. Sorry I couldn't be with you today, but I wanted to go ahead and make sure that we worked our way through the next section in this unit, which is talking about vertex forms. So vertex form is what we see right here. Okay, it takes this format, and it has some similarities to the standard form, which standard form was ax squared plus bx plus c. And in the previous one, we noticed that A, right, that told us if it was steep or flat, and also if it was negative, it was open down. And then the C value told us if it was moving up or down. And so we're going to see what that looks like here in the vertex form for today. So I'm making a slight change. I'm going to put a different x on here. I'm going to do its own set of x's right here. So the parent function is already graphed, and those anchor points are the -2, -1, 0, 1, and 2. And so then we have 4, 1, 0, 1, and 4, and we can see those are already graphed right here. So now we're going to take a look at, notice that the a value out in front is also a 1 here, and that we're doing something to the x value. And so the main way to think about what does x have to be in order for this to be a 0? Well, if I plug in 2 for x, I'm going to get out a 0. And so I'm actually going to start there. That's how I'm going to kind of start. And then because it's kind of hard to just pick, like, how do you know which values to pick if we're not familiar with what the information tells us? So I'm going to start with just trying to make it equal 0, and we'll go from there. So what we're going to do here is I'm going to pick 2 values that are less than that, and I'm going to pick 2 values that are greater than that. And I'm just going to plug them in. I get 1 minus 2 is -1. -1 squared is 1. 0 minus 2 is -2. -2 squared is 4. And then you'll notice here 3 minus 2 is 1. And 4 minus 2 is 2. So we can see here that this was actually my vertex. Okay. We're going to do the same thing here for this other function. And again, remember I forgot to change up these labels. This should be g of x. Let's change this one to say h of x, because that's the whole point of function notation. All right, so again, I'm going to ask myself, what value of x will make this expression equal 0? Well, the opposite of 3 is -3. So if I plug in a -3, -3 plus 3 is 0, and 0 squared is 0. So that's going to give me my starting point. And then I'm going to go ahead and pick 2 values less and 2 values more. And then we'll plug them in. -4 plus 3 is -1, and that squared is 1. And -5 is 2, 1, and 4. All right, so let me go ahead and graph these. We'll do g of x, so 0, 4, 0, 4, 1, 1, 2, 0, 3, 1, and 4, 4. Looks like that. And if we take a look at how we'll label this, so go ahead, this is g of x. Notice how it changed. Notice what happened. It just moved to the right 2 places. So if we take a look at it, it just moved to the right 2 places there. Okay. All right, now let's go ahead and graph h of x. And we have here -3, 0, -4, 1, -1, and -5, and 4. All right, and there is h of x. And if we compare it to the parent function, we see that it moved left 3 places. Well, let's think about that right now. Again, if we take a look at the 2 functions, we have x plus 3 squared. That's for our h of x. And then for our g of x, we have x minus 2 squared. And notice in g of x, to get to the B0, right, it needed to be 2. And look at what was inside. It was the 2. And to get to B0, it needed to be negative 3. Well, the opposite of 3 is negative 3. And so actually, and notice that we're not adding anything. There's nothing being added onto here. All right? So our vertex, actually, this is where the vertex form comes from. Our vertex are these 2 values right here. If we were to take a look at the vertex here for both of these functions, so again, this is g of x. This one is h of x. Right? If we take a look at the vertex is negative 3 and 0. And then this one was 2 and 0. And if we take a look at that format, right? Okay, so what we're doing here is that in this format, it takes the format of minus. Well, okay, how am I getting this to be vertex negative 3? Because x minus a negative 3, that double negative becomes a plus. So when something's happening to the x, it's actually opposite of what we think, and it looks different. We are, so again, we are subtracting a negative, but it's going to look like it's a positive. So what's really happening here is that if our h value is greater than 0, then we're going to go ahead and we're going to slide to the left, like we did in h of x. Again, look at that. All right. And if our h value is less than 0, we're actually going to slide to the right. Oops, sorry, I mixed that up. It's just waiting. Right? JK. If h is greater than 0, our h value, because again, this isn't greater than 0. It looks like it's greater than 0, but it's not. Remember, it's minus and negative. So we're actually going to go ahead and, so if it's greater than 0, which this one is, we're sliding it to the right. And this is where we put in before that it looks negative, but really it's not. But really it's positive because we're subtracting. And if h is less than 0, again, that's what happens when we do minus a negative 3, right? We have to think of that as x minus a negative 3. So that tells us that our h value is less than 0. We're going to go to the left. So it looks positive, but it's really negative. All right? And so our vertex is from these 2 values. So the reason that this is called vertex form is because we can quickly recognize the vertex without having to put in points to guess and check this. All right? So now if we take a look at the domain for all of these, it's still, all of them are all real numbers. The range is still the same. We didn't go any up or down or anything. So the range for all of these is 0 to infinity. Now our vertex is different for all 3 because they moved left or right. And that also means that our axis of symmetry is different for all 3. Because as soon as we slide it anywhere, our axis, if we go left or right, our axis of symmetry is going to change. So when it was the parent function, it's the x-axis, which is, the y-axis, which is 0. Here it's x equals 2, and here it's x equals negative 3. So once you know your vertex, you know your axis of symmetry, right? All right, and from there you can then fill out your y-intercepts, your x-intercepts. We can see our maximum and our minimums and where they open up, okay? Notice that there was no multiplier. Like look out in front here at this A, right? This A takes on the same impact as what it would in the standard form one. When it was negative, it would open down. When it's positive, it opens up. If we multiply it by 1/2, we're going to make it flatter. And if we multiply it by a number greater than 1, we're going to make it steeper. So let's take a look right there at the next example. And I want us to actually take a look at this and kind of start using the equation to help us out. It actually will speed up the graphing process as well. So remember, this right here is our vertex. So we can look right here and we can see that we're subtracting 2 and we're doing a minus 3. So that tells me right away that my vertex is going to be 2, negative 3. And the other thing I can do too is that this minus 2, remember it's opposite of what we think. We think we want to go left 2, but we really want to go right 2 places. And this k value is like what the c value was. It can tell us if we're going to go up and down. And because it's negative, we're going to go down. So I'm going to start from one of my anchor points, and I'm going to just follow those directions. I'm going to go right 2 and down 3, and I'm going to graph the point. All right, I'm going to go to the right 2 and down 3, to the right 2 and down 3. And I can do that for each point. 1, 2, 1, 2, 3. And now without even getting and plugging in numbers into my chart over here, I was able to find some values. Now I can check that out. Let me plug in the values that I did. When I plug in 0, I get negative 2 squared, which is 4, and 4 minus 3 is 1, and that's what I graphed. When I plug in 1, right, I get negative 1 squared minus 3, which is negative 2, that's what I got. And so you can see that when I plug in those values, the ones that I graphed are correct. Okay, so my axis of symmetry, so just from there, I was able to get my axis of symmetry, x equals 2. My domain is still the same. My range, the lowest value I go is negative 3, and I go off into infinity. My y-intercept is 0, 1. X-intercepts, you might have to go ahead and just estimate for right now. I'm okay if we kind of just leave this blank. We're going to talk more about x-intercepts in the next section here. All right, we have a minimum, because again, it's opening up. It opens up, and my minimum is my vertex. And notice that I didn't multiply by anything, so it's still the same. The a value was 1. Okay. All right, so let's see one more with this example here. Now notice here we have this multiplier in here. And I only have 15 minutes for this video, so I'm actually going to stop right here, and I'll come back for the next part.